You told me a story earlier. I'd wonder if you could humor me and repeat it about, I think you were mentioning tomatoes and some work being done about genetic expression.
Yeah. So we searched the world for somebody who was sort of the world's expert in photosynthesis and the movement of carbon within the plant, because we were looking at the way, we knew we were doing this nutrient enhancement, but we weren't 100% sure on how that nutrient enhancement was being capitalized, how it was started really. And so we found a professor in a university in Spain, and we sent some product to her, and she did some testing on tomato plants. I'll correct the language for the American audience.
Thank you very much.
So some of the results from that was stunned us. Actually, we found that's one of the things we found about the photosynthesis being greedy, is that we found these extra stomata. She was the one that discovered the extra stomata being grown on all the new leaves. But what she did was she's written a paper on that. That's a published paper at the moment out there. But she wanted to take it one step further. So she actually mapped the genetics of the tomato plants in the control and that were treated, and overlapped them. When they're overlapped, the software program, I guess, that she's using draws red lines where there's differences in the gene expressions that are turned on. And when you look at these two maps over each other, and you can see where the genes have been turned on, those genes are all in the metabolism, in metabolizing certain compounds. So we've always called the product a nutrient enhancer, but we've always known that our secondary metabolites, being the flavonoids, are triggering metabolism. So now we've proven it's 100% proven that it's triggering this metabolism in the plant, which the plant's the genes are there, they're just not turned on, right? So we're not making genes, we're just triggering their response.
That's awesome. That's the science of epigenetics rather than genetic modification, which has kind of been the most
correct,
focused on area of science when it comes to trying to solve problems in different areas. Is we need to modify the genes, genetically engineer something.
Yeah.
And now we're finding that no, we actually need to enhance or change the environment, and that will affect how genes are expressed and how they're turned on or turned off. So that's exciting. That's the new frontier, I think, is
sure.
Epigenetics rather than gene editing. And so what you're describing is exactly that these plants these compounds that plants produce have the ability to change how genes are expressed and turn them on and turn them off. That's really exciting.
Yeah. And I think, we have the saying within the business, I suppose it's not unique, but you're working with nature, not against it. I mean, if you're working against nature using a lot of synthetic chemicals, and you're fighting yourself. You're going to meet yourself back on the other end, trying to figure out what problem have I introduced by taking that problem away. But nature has been doing it a lot. I tell this story a bit. I told it today earlier on. A guy came up to me at a trade show one time and he said, Kevin, these plants know how to grow before we came along. They knew how to do this before we tried to force them to grow. So you just got to go back and let these plants grow the way that they naturally should. Mm-hmm. And that's hopefully what we're in the forefront, and companies like your company are in the forefront of making those changes in the way agriculture will be done in the future.